What do you understand by mole? 1 mole is the amount of substance that contains as many entities or particles as there are atoms in exactly 12 grams of carbon-12 isotope. So how many atoms are there? There are 6.022 into 10 raised to 23 atoms of carbon in 12 grams of carbon-12 isotope. It is such a big number. Who has counted such a big number? And how do they calculate 6.022 into 10 raised to 23 atoms are there in 12 grams of carbon? For that calculation, they have calculated mass of one atom of carbon-12 isotope, and it is determined by mass spectrometer. And it is found to be 1.992648 into 10 raised to minus 23 grams. So when we divide 12 grams by the mass of one atom of carbon, we can get the number of atoms present in 12 grams of carbon. So when you place the value, you will get 6.022 into 10 raised to 23 atoms. So that's how they have calculated that there are so many atoms present in 12 grams of carbon. So from this calculation, we come to know that 1 mole is the amount of substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12 isotope. So how many atoms are there? There are 6.022 into 10 raised to 23 atoms. Like 1 dozen means 12 objects. It can be banana, apple, car or dolls or anything. Similarly, 1 mole means 6.022 into 10 raised to 23 objects. It can be electrons, atoms, molecules or anything. For example, 1 mole of oxygen atoms means 6.022 into 10 raised to 23 atoms of oxygen. 1 mole of oxygen molecules means O2. It means 6.022 into 10 raised to 23 molecules of oxygen. If I say 1 mole of sodium chloride, it means 6.022 into 10 raised to 23 formula units of NaCl. We use formula unit for ionic compounds only, that I have discussed in my previous video. So how do we measure 1 mole of anything? Do we have to count such a big number? No, you just have to weigh 6.022 into 10 raised to 23 objects. For example, if I want to weigh 1 mole of an element, 1 mole will contain 6.022 into 10 raised to 23 atoms of that element. And it exactly weigh equal to its gram atomic mass, or you can say molar mass of that element. Similarly, if I want to weigh 1 mole of a molecule, it will contain 6.022 into 10 raised to 23 molecules, and it exactly weigh equal to its gram molecular mass, or you can say equal to its molar mass. So let's calculate. 1 mole of sodium. Its atomic mass is 23U, that you can find in periodic table. To get the gram atomic mass, you just have to replace U with G. So you will get 23 grams. And this is the gram atomic mass of sodium. Atomic mass is the mass of one atom of sodium, while gram atomic mass is the mass of 1 mole of sodium, or you can say it is the molar mass of sodium. So 1 mole of sodium weigh exactly equal to 23 grams of sodium. Similarly, you can calculate the mass of 1 mole of oxygen. First of all, find out the atomic mass of oxygen from periodic table. So you will get 16U. Now replace this U with G to get the gram atomic mass of oxygen. So here you will get 16 grams, and this is the molar mass of oxygen, or you can say it is the mass of 1 mole of oxygen. Similarly, you can calculate the mass of 1 mole of oxygen gas. Oxygen gas means O2, and it is a molecule. So first of all, calculate the molecular mass of O2. Here, mass of oxygen is 16U, that you can find in periodic table. Now multiply it by 2, as there are 2 atoms of oxygen in O2. After multiplying, you will get 32U, and it is the molecular mass of O2. Now replace this U with G to get gram molecular mass. So you will get 32 gram. It is the mass of 1 mole of O2, or it is the molar mass of oxygen gas. Now try to calculate the mass of 1 mole of water. Water is a molecule, so you have to calculate the molecular mass of water. Mass of hydrogen is 1U multiplied by 2 as there are 2 atoms of hydrogen, plus mass of oxygen, that is 16U. When you solve it, you will get 18U. So it is the molecular mass of water. Now replace this U with G. So here you will get 18G. This is the gram molecular mass. This is the mass of 1 mole of water, or you can say it is the molar mass of water. Now you know how much 1 mole of any substance weighs. So you can calculate the number of moles also. By using the formula, given mass divided by molar mass is equal to number of moles. Now let's apply this formula to solve the problem based on it. Calculate the number of moles and molecules of ammonia present in 34 grams of ammonia. Its formula is NH3. We have the formula number of moles is equal to given mass divided by molar mass. Given mass is 34 gram and you have to calculate molar mass of ammonia. First of all, calculate the molecular mass of ammonia, and it is equal to the average atomic mass of nitrogen plus average atomic mass of hydrogen multiplied by 3, as there are 3 atoms of hydrogen. Average atomic mass of nitrogen is 14U and average atomic mass of hydrogen is 1U multiplied by 3. On solving it, you will get 17U and it is the molecular mass of ammonia. Now replace this U with G to get the molar mass of ammonia. So here you will get 17 grams per mole, that is the molar mass of ammonia. Now place the value in the given formula. So here you will get 34 grams divided by 17 grams per mole. Grams will get cancelled out with grams. 17 ones are 17 twos are 34. So here you will get 2 moles of ammonia present in 34 grams of ammonia. We know 1 mole ammonia contains 6.022 into 10 raised to 23 molecules of ammonia. So 2 moles will contain 6.022 into 10 raised to 23 multiplied by 2 will be equal to 1.2 into 10 raised to 24 molecules of ammonia. So now we learn to calculate moles and molecules of any substance. But is there any difference in case of gases? How do we measure moles of a gas? 1 mole of any gas occupies volume of 22.4 dm³ at a standard temperature and pressure condition, or you can say STP. Standard temperature is 0 degrees centigrade and standard pressure is 1 atmosphere pressure. For example, there are 3 balloons having same volume 22.4 dm³. One is filled with carbon dioxide, so it will contain 1 mole of carbon dioxide. Second one is filled with oxygen, so it will contain 1 mole of oxygen. And the third one will contain 1 mole of N2. The volume of 22.4 dm³ at STP, standard temperature and pressure condition, is known as molar volume of a gas, and it is fixed for all the gases. For example, this balloon is filled with 22.4 dm³ of nitrogen gas. That means it contains 1 mole of nitrogen. And another balloon is filled with 44.8 dm³ of O2 gas. So it will contain 2 moles of oxygen. Previously, STP was the condition of 1 atmosphere pressure and 0 degrees centigrade temperature. But now IUPAC has recently changed the standard pressure from 1 atmosphere to 1 bar. That's why the value of molar volume also has changed. Now it is 22.71 dm³. It is equal to 1 mole. Though we are still using 22.4 dm³ to solve numerical problems based on it. Here is the formula to calculate the number of moles of a gas. Given volume of a gas divided by 22.4 dm³ per mole. That is the molar volume of any gas, and you will get number of moles. So let's use this formula. Calculate the number of moles and molecules of ammonia gas in a volume 67.2 dm³ of it measured at STP. So we have the formula number of moles is equal to given volume divided by 22.4 dm³ per mole. Given volume is 67.2 dm cube. Now place the values in the formula. So here you will get 67.2 dm cube divided by 22.4 dm cube per mole. When you solve it, dm cube will get cancelled out with dm cube, and on solving you will get 3 moles. So here we have calculated the number of moles. Now we have to calculate number of molecules of ammonia. And we know 1 mole of ammonia contains 6.022 into 10 raised to 23 molecules of ammonia. So 3 moles will contain 6.022 into 10 raised to 23 multiplied by 3. On solving it, you will get 1.8 into 10 raised to 24 molecules of ammonia. So here we have calculated the number of molecules also. To practice more problems on mole concept, you can find the link of my video in the description box.